Good afternoon, everyone. Thanks for already being in the presentation. We will wait a few minutes before we start at around 6. Okay. Good evening, everyone. Welcome to our session, information session. We chose the YouTube feature to do the session, but then we unfortunately discovered that we cannot have a question session with voices, and we will have to type questions. With the sessions that we have with the class, we will have a platform where we can talk and ask live questions, etc. So apologies for that. So you can start to think and formulate your questions in text, and it would have been better to do it with voice. But okay, we are somewhat limited in that respect. Apologies for that. Okay, so let's get started. I just want to quickly get my pointer right. Good. Okay, so just a bit of background about the course that we are planning to give this year. It's the first time that we are doing this, and we identified a bit of a gap over a long period of time, experience with students over many years, etc., both at school level but also at university level, where students come into the course not sure what to take, whether they should do actual science. The only thing that students basically know when we ask students about it in their early first year studies, for example, is the only reason why they do actuarial science is because they are good at mathematics and maybe they are going to get rich or something like that. But beyond that, they don't really know what they are doing, don't have a feel for the subject, and don't have a bit of a bigger picture. And we think that there is quite a gap for doing this at a bit earlier stage for school kids, not only telling them what actual science is about, but also giving, let's say, those somewhat higher performing students a taste of what they will be what they will be confronted with in terms of some of the mathematics, some of the statistics, calculations, and problem-solving issues and challenges that they will have to that they will encounter in their studies. We will basically cover some of that not at too advanced a level. Of course, one can go really far with actuarial mathematics, etc. So we tried to find a balance between, let's say, what is realistic for school children and what is also useful as, let's say, a bridge between school and university. So I prepared a few slides just as some basic information. We are really interested in questions from parents about the course and everything it involves. I will cover most of the admin and everything that I anticipated that you might want to know, but really feel free to ask questions in this forum. And if you have even more questions, please feel free to contact us, phone us, and we are really open to discuss any further issues. So to jump into this, what we will cover, just some of the admin. We'll just start with saying what it's about, how much it costs, and those things. And then we'll talk a little bit about why we want to do this, why we do need actuarial science, and what actuarial science is about in general, and also link it a bit to the kids, their futures, etc. Yes, we'll discuss some examples of, in a broader sense, what we will try to achieve, or let's say kind of work that we will try to cover, and let them help understand or get a command over. And in the same breath, we just want to talk a bit about the topic becoming future-proof. We want to think a little bit at the future. We know the future, the workplace, and we must say everybody talks about AI, but it is becoming a massive reality for us, where we see that even actuaries, but not only actuaries, that are, let's say, only technically proficient and can do technically advanced maths is not enough anymore. AI can do those things for us. So even actuaries, but everybody else, lawyers, everybody needs to adapt to that and become a bit more than just the minimum that a profession or a course or a degree offers. So we want to cover that as well and make students a bit and help them adapt to that situation and be ready for that when they are finished with their studies, when they're busy with their studies, to have that context. And okay, but let me talk more about that when we get there. And then just about next steps. I mean, in terms of the course, what do we do next? Who do we contact if you are interested in going on or taking the step to join us? Okay, just a bit of admin. So I'm not doing it in my capacity as a university professor. I am involved with the University of Pretoria, but we are doing this as something separate. Hopefully we will get endorsement later on when we offer it next year and beyond, but that is currently it is our own initiative where we try to cover this gap. So I will be the lecturer of the course. My co-developer and support is Anisha Garib. We're doing this under the auspices of the company Inspired Africa. So Anisha is helping also on the administrative side and co-developing the work. Okay, some more admin. I must press this button. So as we said, we gave this information in the WhatsApp groups, etc. Just to get that out of the way, we will have weekly lectures, live lectures. 4 o'clock in the afternoons, quite a few parents told us that the kids are busy during those times. It's difficult to choose a time that suits everyone. So that's what we currently decided upon. Of course, it's possible we will record our sessions for those that want to watch it later. It's not ideal. I would say that one should carefully consider whether, if you really cannot do the live lectures and only look at the videos afterwards, it might not be as great. So one should carefully consider if it's worthwhile. But yes, we have other activities that students will be able to participate in besides only the lectures. Of course, in terms of time commitment, what we estimate is, yes, we have the lecture, that's about an hour. Let's say we have the 45 minutes plus some question time, and then we will every now and then give some assignments or something for kids to do at home to think about, to go and read up. So there will be somewhat more, let's say for the ideal student that will do something beyond only the lectures. That will take about 1 to 2 hours per week of their time. Of course, somewhat flexible besides the lecture itself. And then our first lecture is the 4th of February, the Wednesday at 4 o'clock. We will still announce, I think we will use a different platform than YouTube to have a bit of a better two-way communication. Okay, and then to get this out of the way, the pricing, 500 rands a month, and it runs from February to November. We know November is exam time, so we will still think a little bit about that, whether how we will do that, not to clash too much with exams and those things. So that is currently the plan, but that might change, where we might decide to change the schedule a bit to make way for exams, for example. Okay, so with some admin out of the way, let's quickly just talk about why we have the course, why we have actuarial science, and the first few things, just in general, and it has something to do with what actuaries, why we are there, why they are necessary. It's mostly about the future, okay? So major companies, smaller companies need to make decisions in an uncertain future. They might need to move into markets. They might have, of course, the cradle of actuarial science is the insurance world. They need to insure someone for the rest of their lives. So we need to think about the future, estimate what might happen in future. In terms of life insurance, the estimates are quite accurate, but there are other fields where actuaries move in, like banking and project management, where the future events are less certain and need a bit more research, and actuaries are starting to get into those areas more and more beyond just insurance. And the second major point, yes, about the future, we try as far as possible to quantify it, okay? So we are not just looking into a crystal ball. We try to add some mathematics to that and build on what we know, the data that we have. So yes, we want to quantify risk, quantify, in a way, time, the time value of money. Money today is not the same. A million rands today is by far not the same as a million rands 10 years from now. So yes, want to quantify in terms of time. And increasingly important, where actuaries are getting into more and more, is we need to quantify human behavior. There we can think a bit in terms of discovery and those guys that try to influence human behavior and make it something quantifiable, make something profitable out of that. So yes, human behavior and other kinds of behavior are becoming more and more important. So actuarial science lies very much at the intersection where mathematics and the real world meet, and the applications beyond those that I mentioned now are really very many. But I think a basic example when we go through this to think of is insurance, for example, where we have uncertainty about someone's life, but we need to make decisions to, for example, not go bankrupt when we need to pay out policies, etc. So yes, a lot about the future. This is a very brief mention of that. One can have quite a course in itself on what actuarial science is about and what all of these things are about. In terms of, so this is more in a general sense, but what it also means for our kids is, so why do everybody want to do actuarial science these days? And well, a brief answer, everybody thinks that actuaries make a lot of money, which in some cases is not wrong. But what make that kind of true is that the actuarial science, let's say the actuarial syllabus, and the whole, let's say, training program provide students with a unique set of skills, where we have, yes, those that are good at mathematics. We have a lot of quantitative skills, mathematics and statistics, but something that makes it strong, and I think that's what one reason why it is such a sought after, let's say, why students with this degree or this qualification are sought after, is it's a combination with quantitative with some soft skills. in the undergraduate, when you do your normal degree, for example, you do all the math and the statistics, but then later, in the later courses, one do much more mature stuff, and it's more wordy, and you need to explain what you do, the so-called soft skills. And at the end, you get a kind of a well-rounded person that can do the actual work, but also is able to explain what they do to different audiences, to the board of directors who are not mathematicians, to mathematicians, etc. So that is something that kind of makes actuarial science stand out to some extent relative to many other also heavily mathematical courses. Yes, indeed, the employment opportunities, that is a reality. We, um, we need to take that into account. And historically, we had quite good employment success for our graduates, especially those that go up to the honors level. If you do the degree only, you are a strong data scientist, you can do a lot. What we know really well is that our honors group, for example, and honors groups in general, I'm not only talking about where I come from, historically we had kind of very close to 100% employment placements. Things are changing a bit now with AI, and we need to talk a bit about that, and we will. But that is something that strongly goes for the actual direction. And yes, furthermore, actuaries, we find that a lot of actuaries are doing traditional actuarial work, but we also see that quite a number of actuarial people do something else than just basic actuarial science. They move into creating their own businesses. Some of them move into very non-traditional fields where future uncertainties need to be talked about, etc. So actuaries with their skills and their strong bases have a lot of potential to develop into other fields as well. It's really somewhat easy to move from actuarial science into other fields, a bit easier than moving from other fields into actuarial science. So that is quite a significant strength. Just to speak a little bit more about the science itself, it's highly what we call interdisciplinary in the academic world. Actuarial science, let's say, cuts across a lot of fields. There in the middle, I write data science. I could have just written actuarial science, but traditionally, actuarial science were mostly focused on the insurance world. It started long ago. People like Halley from Halley's Comet started to work out the mathematics behind insurance, etc. How do you make money with these uncertain payments that you need to make and that you get? And over time, much more recently, let's say more with the development of advanced computing, the actuarial type of questions, people started to realize that it has application in many other cases. Let us think of a life that might continue or not. One can just as well think of a banking loan that might continue to be paid or not from the point of view of the bank. It is the same mathematics, just different things. And then many other things. We have extreme risk. We saw major financial crashes, etc. And companies want to provide for that. Banks, for example, and insurance companies must provide for that. And they need people to help them with those calculations. And then there's, of course, strong overlap with economics. And I write here regulation, but also with the legal side. Actuarial science, of course, has a lot to do with contracts. So what we have when we do proper actuarial science and you go all the way to becoming an actuary is that one knows a bit about all of these areas and maybe a bit more. I didn't write here mathematics and statistics. That is assumed that it's part of this. But what makes this really strong, actuaries knows a bit. They're not deep experts in necessarily all of these areas, but they know enough to be able to lead a team, to get a bunch of experts together. They know what to do. They know what kind of expertise they need. And that's why I have this slide, is to motivate. And that's one reason why actuaries, one will often see actuaries end up in somewhat senior positions in companies. And those are the kind of positions I think that we think will most likely survive in the longer future when we work with AI stronger, etc. We have a broad base of knowledge. We are not experts, total experts. We are not pure mathematicians. We are not pure economists. We know enough of everything to be able to build and lead a strong team. And that is a major strength of actuarial science as well. Okay, so just the three main features of actuarial science that I identified when we think about what our kids need to do. Something that I want to install in them is the idea of the time value of money. And that is well, we will talk a bit, we will start before we talk about the time value of money. We'll talk a bit about, be a bit more philosophical. What is money? Where does it come from? Where does banks come from? All those things. But yes, an important, I made a little silly slide here just to instill the idea that the value of money, the time value of money is crucial for actuaries, especially when we think about the long term. Today, 100 Rand can barely buy you a coffee and a sandwich. In 10 years, maybe only a coffee. In 2020 and 25 years from now, one will not be able to buy much else than maybe just a friendly smile. And well, ChatGPT told me to tell this joke. That's maybe why pensioners complain about the price of coffee. The idea that we want to instill in students is that the time value of money is important. We need to, when we are actuaries, we might often be involved with pensions that start paying in 25, 30, longer periods of time. And we need to think about, if someone thinks, that's my next example, if someone thinks that 10 million rands in 25 years, they will retire with 10 million rands 25 years from now, it sounds a lot. But when one looks at the calculations and we bring it to today's terms, it will equate to 20,000 as if you retire today with the notional 10 million rand. That's 10 million rand in 25 years. If we take it back, bring it back to today, it's about 20,000 rands per month. It might not be such a nice, buy you such a nice pension in 25 years from now. And those kind of advice and those kind of calculations is what actuaries are needed for. Not only in pensions, there's actually not that many actuaries that work in pensions, but quite a few, not the majority. And but the long-term thinking, time value of money, crucial. And that's one thing that we want to instill with the kids and actuarial students in general. Then the important aspect that we need to cover and that we want to install is uncertainty. Time value of money is one thing, but then when we think about the future, what might happen in future, and thinking about maybe financial cash flows, for example, that might come in and out, these cash flows have a probability. They have uncertainty attached to them, and we need to quantify that. The mathematics for insurance, for some of the banking kind of problems, is nicely worked out, complex, but nicely worked out. But in some cases with much more complex phenomena, it's quite a challenge, and it's not becoming easier. I got a nice quote here from Yogi Berra. I think he was a baseball coach who said things very innocently, and then it turned into something proficient. He said, "The future ain't what it used to be." And yes, at the business of actuaries is the future. And for us, let's say in the 60s, let's think about 50, 60 years ago, there were actuaries then as well, prominent actuaries. The world was more stable. A lot of nice mathematics were worked out. But in today's world, the future is not as stable and not as certain anymore, which is, of course, a threat to many of us, but it's a massive opportunity for people like actuaries. Think about a more interconnected world. One cannot just, if you work for a bank, it is not feasible anymore to just go and work out the future for your bank. It's part of a wider world. Things are interconnected locally, internationally, etc. We have behavior of people that are interconnected with one another, social media, etc. And we need to take that behavior into account, because we are seeing in real applications that such kind of interconnectedness, complexity can be quantified. Not easy, but that's the kind of thinking and the thinking that we want to instill with our students and of course at an early stage as well. So I hope that makes it, the future ain't what it used to be. The future long ago, when you were an actuary long ago, the future was kind of straightforward to model. Currently, it is quite complex. and needs more techniques, massive opportunities for actuaries. And then an aspect that I want to bring in, it's not completely mainstream actuarial science yet, but something that actuaries will get into more and more is in the behavioral world. And I mentioned it a bit earlier. Let's think about the insurance side. A lot of us are familiar with the idea behind Discovery, for example, and others. And Discovery is a prime example. The old way of doing actuarial science is I take Mr. A, I look at him, he's a male, he is this age, he works there, he has an education, and we have nice tables and books that we can look up someone with this age, someone with this credentials. That's his premium that he needs to pay for his medical aid. Currently, the way of thinking is we take in anybody. We take in a bad risk, give him a nice watch, give him nice incentives, and make it actually make it a nice game for them to improve their health. And you take a bad risk and turn it into a good risk. And that is the new way of thinking where yes, I'm not trying to promote. I don't get anything from Discovery, but that's the trick that they managed with rich data and to change risk and to quantify behavior. And that is where, to a large extent, actuarial science and all sciences, data science is, let's say, is barreling towards to model and understand these complex risks. But not only in the insurance world, also in investments. And people are going really deeply into to modeling people's behavior. So some of us might be familiar with investment, our own private investments where we play around with shares. And this curve might seem a bit, well, if you read through it, let's go through it. It might feel a bit familiar, where let us say you put some money and you buy your shares. You have some optimism. That's why you decided to do it. It goes up, get a bit of excited, goes more up, you're thrilled, there's euphoria, and then often it goes down. There's anxiety, there's denial. All of us might have experienced that. Those that are investing a bit, I certainly do have that experience, etc. Depression, panic, capitulation, etc. There's a lot of emotional, psychological issues that goes hand in hand with many financial decisions that people make. And those are things that are to an extent quantifiable, not perfectly, but it's new fields. And there we can see it, another aspect of the interdisciplinary nature of it's actuarial science, where suddenly here we have an overlap with something like psychology. So we often have our kids that are, for example, interested in something like psychology, and they say, no, I don't want to do this actuarial science thing. It's the dead science, just dead maths and so on. There is so much opportunity for kids to do interesting things beyond just the pure mathematics. You can overlap with psychology and all these things that are open to actuaries and to quantification. I just have a few notes here about, yes, these kind of behavioral stuff is used in insurance, in the banking world, investing, etc. Okay, I don't want to make too much of a lecture of actuarial science. I don't want to, well, maybe I should have an adult actuarial science course as well. Then we can go deeper into these things. But I just wanted to give the kind of issues that we are interested in, that we want to get kids familiar with. Of course, with school kids, we will not be able to go deeply into behavioral finance and quantifying that. We will just get a basic start with that. So back to a bit more closer to our course. What we thought is that we will, throughout a year, we would like to have some assessments. We consider for this just to be lectures and fun lectures, but I think a bit true to the actual actuarial education, it's all tied to assessment, and we want to have to get students somewhat exposed to that as well. To write an exam, we will make tests to be at the same pace, 1 mark per 1.8 minutes per 1 mark, etc., to write real actuarial exams. We want to give them a taste of that. But what we don't want to do is, at school level, is to make it so daunting for them that they are really so scared of actuarial science that they run away from it. So we want to make it realistic, but also somewhat true to the actuarial culture. So in quarter 1, we thought of not starting with with the mathematical stuff immediately. We want to orient the kids a little bit in the first quarter. We will talk a bit. Okay, so this is about assessments, but also about the course in general. We will talk a bit, somewhat general, to tell them what is actual science, show them nice case studies, show them nice successful people in different directions, etc., to get them, show them what the actuarial profession is about, how to become an actuary, what you need to do, think about your marks, and so on, what you need to have in place to get admitted to university, all those things. We want students to be comfortable with that. That's actually a theme that we want to keep going throughout the year. We want to look at students' marks, and those that fall a bit behind but still want to do it, we want to encourage them and give them some feedback about that as well. In the second quarter, we would like to start some actuarial mathematics, let's say more on the time value of money side that I showed there, and without the probability, without the uncertainty element, just to become comfortable with the time value of money in different contexts. The one I showed you with coffee is now really a straightforward, simple case, but one can have so many variations on the theme, and that's what we really want students to get comfortable with. In first year university, students jump right into those kind of calculations and are somewhat a bit shocked with it. So this will really help with some bridging in that respect. In the third quarter, we want to continue with actuarial mathematics. There we want to bring in a bit more of the uncertainty, the probability side. We will talk, we would like to introduce probability in a nice way to them, interesting, fun way. But then also we would like to have an exam. We call it an exam. We will most likely would like to write it during our lecture time at 4 o'clock on a Wednesday. And not the major exams. Typical actuarial exams are 3 hours and so on. It's long exams and maybe even more. In our case, we are not going to go that far. An hour exam at most is what we have in mind. In quarter 4, there are bigger exams that students need to do, so we decided to rather have a term assignment there. And there we would like to go a bit more into, let's say, we will not be able to make it too complex, but we would like to give students a nice first taste into a real world problem where they can use AI as much as they like. We see in many schools and so on, people are negative and say, stay away from AI. We would like them to use this as if they are an actual actuary working on a problem and come up with a nice solution. In many cases, there won't be one correct answer. They might come up with a nice solution and approach to solve a problem, and that's what we would like to do in quarter 4. So not a hard exam in that quarter, mainly also not to clash with school exams. So just my last 2 points here. Exam number 1 and 2, we aim to, I call it, that's the quarter 2 and quarter 3 exams, what I call year exam 1 and 2. We aim to avoid clashes with school exams. So we will, closer to the date, see what's going on. But as far as possible, we would like to have it during our lecture time, and we will coordinate it. It will not be written at our venues. We will maybe all write it together at home. And the assignments are more flexible. Okay, so the first quarter, students, we just wanted them to get into it, not to be discouraged, or just know what they're busy with before we jump into actual mathematics. So the assignments are a bit more flexible, and the last assignment is something we think might be quite useful and instructive for kids. That will be something that feel a bit more like what they will have in the real world, let's say when they start working as actuaries. Okay, I'm nearly finished. Yes, I think I said most of this already, but what do we want to achieve with the course? Some enrichment for gifted learners. We want kids. I know a lot of kids who decided to go and do actuarial science without, as I said, not knowing much of what it is about. So it will be some. We would like to challenge some of our gifted kids a bit as well. And yeah, so we will not chase away someone that might not be defined as a gifted child, but some of our questions are more appropriate for let's say for those that are strong in maths, maybe science, physical science, etc. Okay, something else that we really want to get students to get used to is that actuarial science is essentially a problem-solving profession. A lot of questions we can solve with mathematics, but even after you did most of the mathematics, you need to make a decision. The board of directors need to make a decision. The hard calculations don't give you all the answers. There are still many questions. So often actuaries are being relied upon when companies make big decisions, and that's another reason why actuaries are often seen in more senior positions in companies. They are relied upon heavily, even when there is somewhat more subjective judgment involved, because we are focused on general problem solving besides just the core actuarial calculations. Okay. Yeah, this is something I already mentioned. Something we do want to achieve is to give kids a nice introduction to actuarial mathematics, see what it looks like. We will do it at a foundational level. Actuarial mathematics can go really far in terms of complexity and so on, and we don't want to go too far. We want students that don't have all the prerequisites. You don't need to have all the calculus and all the alpha maths already in place. We are going to do it somewhat independent of that. Just problems that or let's say some theory that we introduce here, and already with that one we'll be able to introduce some interesting questions and problems there. Okay. Something that we also, I mentioned this, it's a bit of a repetition. We want to introduce students, make them comfortable about the actuarial profession, the qualification, the working environment, tell them a bit of what is needed, how they should prepare to become, to get admitted to a university and to become successful in studies. Think a bit wider than just the core work. Start reading about stuff, politics, and risk, for example, is often has to do with what's going on in a country. When a company needs to decide to invest in a certain country, we need to know what is going on. And students already, well, our kids are naturally not that interested in those things, but we will try to get them a little bit interested in stuff like that. Something that we really want to achieve, I touched on that quite a lot in this talk, is the world is changing a lot. Actuarial science is changing, but the world is changing a lot. We hear from employers, we see every year how the employment numbers change, even for our students who are really sought after in the professional market. But what we see is that, I mentioned it earlier, is that we do see changes in employment patterns where those guys that are, let's say, technical experts, technical actuaries, might not be that certain of a job anymore. You need to be technical, you need to be able to communicate, you need to see the bigger picture, you need to be able to combine that with artificial intelligence, because you will compete with a computer scientist that might, to a large extent, ask ChatGPT, solve this actuarial problem for me, and in an interview, they might outperform an actuary. So we want to get into a situation where we stay at the forefront and prepare students in general for the future. That's what I mean here by the future proofing. But bit of AI professionalism. I don't want to say too much here. Actuarial people often get confronted with conflict of interest and things like that, and we need to talk about that a bit. But yes, we would like to, in a smart and fun way, just introduce a bit of the bigger picture as well, besides just the maths, just how to pass things, etc. And that brings me just to a quote before I go over to question time. Okay. So just to illustrate that, it's not it doesn't look like a very motivational quote. The actuary who is only an actuary is not an actuary. Frank Reddington is a famous actuary, a famous UK actuary. Some of the work that we do are the Reddington equations and everything. So I what it means here is referring to my previous point. We need to be not only look at our let's say minimal, rigid calculations, etc. We need to look a bit wider, and that's one thing that we want to achieve with the course. That students know what they're busy with, know the environment, and go into the actuarial world, actual studies, etc., with a bit of a better picture of what's going on. Okay, so that is my presentation. I have a slide here with that invites you to some questions. We made a QR code here that takes you to our WhatsApp group, if in case you are not on it yet. And there is some WhatsApp contact numbers. Okay, so that is Anisha's number, the WhatsApp number, the 068 number. I will leave this on for question time. And there's also an email that you can write to, but also feel free to arrange a meeting or a discussion if you would like to discuss this a bit further. Okay, I will go over, just got a note here. Okay, so yeah, so I have some, first question that I just want to address is, let me see, do we already have a question? Oh, I see the first question. Is this a one-year course or an ongoing course? What we have in mind, so for the first year, we have to some extent, as the core, we have in mind a somewhat senior student that needs to make a decision soon and needs to decide on actual science. That let's say that there are two scenarios here. We have a strong student, grade 11, that might get in, not sure how well they should do, etc. And we can talk a little bit more about that. The answer is kind of simple, but we can be a bit more specific. You need to do really well, and the cutoff points, I aim for more than 88% or something like that on average, things like that. So for more senior students who are closer to making decisions, needing to get into university, the course will have a value for them. But then also for the younger students who can do something about their, let's say, about their destiny, still improve marks a lot, change behaviors and change and improve, who has a lot of scope to change that. We also want to aim at those. For the first year, we have a fixed course, but for the year after that, we will have a more tailor-made course for different groups as well. So we will maybe have for next year, we will have two streams for the younger guys that want to come in, and then for the older guys, those two groups clearly have essentially different needs. The more senior students are closer to decision making. They have a certain need, and the younger guys can do much more and change their marks, etc. So there is a difference between them. The work is kind of universal, so that required. So in the beginning, we will have the same for everyone, but in due course, we do want to have it as an ongoing course. Yeah. So I hope that answers your question. We will have to work through it next year, but the short answer is this year we have a first year course. We want to make it accessible also for the senior students, but then from next year on, we will adapt it to younger students, to let's say newcomers. Again, we will keep doing this one for the older students, and we will introduce nicer, or let's say more fun problems for the younger kids who might be more in need of fun stuff, for example. Okay, let me go down. Sorry that you guys need to do all of this in text. Will we be able to watch a class later if we miss the live stream? Yes, we are going to record the lessons and questions and so on. We will have to think about that in terms of maybe not all the kids, I don't know, in terms of privacy and so on. So we'll deal with that properly. What we will do for those that are signing up and want to become part, on our website, parents can sign up for, let's say, can create profiles and then also sign up the kids. And there we have a nice system where progress is measured and where we put on the lectures and all information for the course. So once once you are signed up, we will be able to give you much more detailed information of what's going on once you are signed up onto our website. Another question. Is this course suitable for a grade 9 child to join now, or should they rather wait until next year or grade 11? That's a somewhat tough question. I would say that the course can be quite useful for someone in grade 9. So next year we will have a different course for different students. So for someone in grade 9, what will be useful is to start orienting them in terms of the mathematics and the work that we do, and to assess whether they are at the level at this stage to for example, to see if they have potential to get in and what needs work to be done. So that's one aspect that we want to cover, is to start preparing students to cross that hurdle. It's a massive hurdle to get into actuarial science courses at the various, let's say, at the main universities that do give actuarial science. So it's I understand that, yeah, it might feel a bit early. In some cases, grade 11 is a bit too late to get in, unless your marks is already there, unless you are thing that they want to do. But at the grade 9 level, there's still something that one can do to encourage students to improve marks, to change, and to just make the likelihoods a bit better to get into actuarial science. Any other questions? Please feel free. Sorry that I need to do this in text. It feels a bit dry, but okay, that is what we have today. I'll give a few more seconds. Okay, but everyone, thank you very much. Feel free to contact us, and everybody don't want to ask things here in, let's say, in a public setting. So please ask us questions. Send us a message on WhatsApp if we need to call you or talk a bit more about your specific situation, and then yeah, we can take it from there. So thank you very much, everyone that attended. I hope we see you. We see your kids to participate. But yes, I think that there's quite a lot of opportunity to still ask questions and discuss, and we'll be glad to respond to any questions later on as well. Okay, thank you very much, everyone. I'm going to stop the session now. I'm going to leave this on for a while, the information here, but yeah, I'm ending my presentation soon. Oh, there's one more. Thank you very much. Okay, it's not a question. Okay, thanks, everyone. We'll speak hopefully soon again. Okay, goodbye.